Okay, so it looks like we've got everybody we're going to get through right now, so let's get started. If you're watching this on the replay, awesome. Thank you so much for watching. Down below, if you're on, is the remind code if you're not in my class and you want to send me a remind at any time. And tonight we're talking existence theorems. So that's my goal, is to go through, what are the major existence theorems, make sure we know them, and then just do a ton of examples trying to differentiate between when we use each. So we're going to start with the extreme value theorem. And the extreme value theorem is really related to extrema. And when we think about existence theorems, a lot of times you think about writing justifications. You're thinking about writing sentences. You're thinking about writing, there exists a C such that blah, 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 right? EVT is the one that we really don't do that as much for. So here's what EVT actually says. EVT just says, if the function is continuous on the closed, then there must exist a C in AB where f of x is less than f of c for all x. So if f of x is always less than f of c, what that tells me is that f of c is a maximum. So this tells me that there must be an absolute max. This is going the other way. There exists a d such that f of x is greater than f of d, and that means there's an absolute minimum there. So all EVT says is that if it's continuous on the closed interval, there has to be an absolute max and an absolute min. And you have candidates for this. So your candidates are any of the critical values, because obviously those are maxes or mins, or your endpoints, because those could be the max or min. Remember that an endpoint can't be a relative extrema, but it can be an absolute. So in this case, that's not a good picture. In this case, right, these are my endpoints. This is my absolute maximum, but this is my absolute minimum. So one of them is occurring at a critical value, one of them is occurring at an endpoint. So we need to make sure we test both. A function may attain it more than once. For example, the maximum of sine is 1. That happens multiple times. So that's totally fine. Extremes often occur at endpoints, so make sure you test them. And for constant functions, maximum and minimums can be equal. That's fine. So here's how this gets asked, and we've done a lot of this in class. I think we're pretty good at this, but let's make sure we understand this one. So this is an example from the 2004 exam. It says between 0 and 31, so immediately I see closed interval. The rate of change of the number of mosquitoes on a tropical island is this. So this is already a rate. So think about that's a derivative already. There are 1,000 mosquitoes on at t equals 0, so that's your initial. To the nearest whole number, what is the maximum number of mosquitoes between 0 and 31? So I see what is the maximum number. I want the absolute max. So this is calculator active. So the first thing I'm going to do here is I'm going to identify my candidates. And so what that means for me is I need t, and I'm going to want to find the number of mosquitoes. So my endpoints here are 0 and 31. And I know at 0, I'm starting with 1,000. So that's my start. Then what I'm going to do is I'm going to look at R of t, and I'm going to look for where that changes signs, because that's going to be my critical values. This is already a derivative, right? So I'm going to graph this, and doing that, and I know my interval is from 0 to 31. So when I graph this, I'm just going to look from 0 to 31. That's going to be my goal here. So I'm graphing it. I'm going from 0 to 31. I'll show you guys this in a second. And I wind up with this picture. So we've got 2 critical values in there. Now we want a maximum, right? So you can test both critical values, but a maximum is where your derivative changes from positive to negative. So really the only candidate for a maximum is this first critical value, because that would be a minimum value. So I'm going to do second calc 0, and I'm going to find that value. So I went to the left of it, I'm to the right of it. So that's at 7.8539816. 7.853.816. Okay? And now I need to find what the value of mosquitoes were there. So anytime I'm talking about that I'm given a rate and I want to find an amount of something, I'm talking about initial plus net change. So my initial is 1,000. And then I'm talking about the integral from 0 to that of r. That would give me that value. This one I'm talking about 1,000 plus the integral from 0 to 31 of r. Right? And so what I'm looking at for my absolute max and absolute min is I want to see, or absolute max is which of these is actually the maximum. So I would plug those two into my calculator. Whichever one is actually the highest is my max. So here's how this is graded. This was a 4-pointer. So absolute max value, did you use an integral? Did you have the correct answer? And then your actual analysis, did you compute the interior critical points? And did you complete the analysis? So that's what they're looking for on that. Okay, let's look at this next one. The amount of water in a storage tank is modeled by the continuous function on the interval from 0 to 7, where t is measured in hours. In this model, rates are given as follows. The rate at which the water enters the tank is f. The rate at which the water leaves the tank is g. And g is piecewise linear. It looks like this. So f and g are both pictured. This is f, this is g, right? G has the jump in it. And they tell me that these intersect at these two values. At t equals 0, the amount of water in the tank is 5,000. So again, I see my initial there. And it says, at what time is the amount of water in the tank the greatest? So that's saying when is there an absolute max? To the nearest gallon, compute the amount of water, justify your answer. So I need to look at this interval. So I know I'm going from 0 to 7. So I'm going to start with that in my table. So I'm going to say, okay, I'm going to go 0 to 7, and I'm going to look at t, and then amount of water, so gallons of water. Right? So I know initially it's 5,000. They give that to me. At 7, I can figure out what that is, and we'll double check that in a second. But now what I need to do is figure out my critical values. And so that's going to be where the rate of change equals 0. Now, my rate of change here is going to be the rate it comes in minus the rate it comes out. So f of t minus g of t. And I want to look at where this either equals 0 or does not exist. So let's look at that. F of t minus g of t equals 0 does not exist. Well, that would happen anywhere f and g are equal. So this is one point where they're equal. This is a point where that does not exist. And this is another point where they're equal. And so I really have 3 initial candidates. And we can think about this logically. For it to be a maximum, the greatest value, I can think about it a little bit this way. So if this is f and this is g, and I think about f minus g, I'm going to kind of make a table of values here. So I'm going to call that a, I'm going to call this b, and I'm going to call that c. So between those values, right, if you do f minus g on this first interval, you are going to get a negative value. G is bigger than f. If you do it on this second interval in here, you are going to get a positive value. If you do it on the third interval here, you're going to get a negative value. And if you do it on the fourth interval over here, you're going to get a positive value. Now, you don't need to do this. You could say, I'm going to examine all 3 places and see what happens. But what I'm looking at is there's really only one candidate that could be a maximum, and it's at B, which we said was 3. So those are my candidates. So this is what this looks like. My candidates should be 0, 3, and 7. If you had the other 2 candidates, it wouldn't be wrong. You just don't need it. Your initial is 5,000, and then you're going to do the initial plus the net change, the initial plus the net change. And here what they did was they started at 3, so they used this value from up above so that they could just add on to that. And so it's at max at 3 hours, and the max is 51.27. This, when they say justify, is what they mean. So this came out to be 5 points. The t equals 3 needed to be a candidate. Again, the other 2 weren't wrong, but you only needed that one. You needed the integrand, so the thing in the integral, the f minus g. you needed one answer there, one answer there, and then you needed your conclusion. So this is how EVT is going to show up. Or it's going to show up in multiple choice that just look weird, but you have to reason through them. And we'll talk a little bit more about those. All right, send questions if you have them. We'll do one last one of these. So just part C, find the absolute min and absolute max of G. So I'm going to start by saying this is a closed interval. So my end candidates are -4 and 7. I'm going to look for critical values. So -2, 2, 6, and 10, right? And you could actually eliminate some of those because you don't actually have a sign change there. So you really only need -2 and 6, actually. But this would be what we would want to do. We would want to use those values and then find the integral. So if we're doing the integral from 2 to x, we would say, for instance, for the first one, start at 2. This is going to be -8 because you're going backwards, plus another 4 because you're below, and that's where that -4 comes from. So you're just adding up the areas under the curve. Your absolute minimum is at -8, and your absolute maximum is 8. Okay, same exact thing. Again, 4 points on that. Okay, let's talk IVT. So the logic behind IVT is this. Intermediate, in between, right? If you're going 30 miles an hour, and then you're going 60 miles an hour, at some point you had to have gone 50 miles an hour because your velocity here would be a continuous function. So that's the basic idea. The formal statement is this. If the function is continuous on the closed interval, for every value between f of a and f of b, intermediate, there is at least one c value on the open interval where f of c equals that value. Okay? So here's how you would want to answer this. Since f is continuous on the closed interval and f of a is less than whatever is less than f of b, by IVT there exists a c on AB such that f of this should be c equals that value. And the key thing here is continuous on the closed, must be continuous on a closed. You need those closed and endpoints. And it's called the intermediate value theorem. So you need this intermediate thing, the part that sandwiches it and says it's in between. So we're going to take a look at a couple problems here. So let's look at this one. Train A runs back and forth on an east-west section of the railroad track. Train A's velocity is given here. Selected values for VA of t are given in the table. Does the data in the table support the idea that train A's velocity is -100 meters per minute at some time t between 5 and 8? That's my question. So I see that they're giving me velocity and they're asking about velocity. So that's intermediate value theorem because we're given the function we're asked about. And so what I'm going to do is I'm going to kind of think through this logically first. If I'm going from 5 to 8, if I start at 40 and I end up -120, do I have to cross -100 at some point? Yeah, absolutely. So here's your argument. We see here that this is differentiable. That implies it's continuous. So since f is differentiable, it is continuous. And write the words out, you can handle it, on the closed interval. C, C, right? Continuous, closed. Okay? And we know that VA of 8, that should be an 8, not an A, VA of 8 is less than -100, which is less than VA of 5. So it's intermediate. So by IVT, there exists a C on the open interval from A to B. And notice I'm literally copying this. Okay? Open interval, such that VA of C equals -100. And I would answer yes here too, if it says does the data. Continue to send questions if you have them. All right, we're going to do another one of these. Another IVT here. No, we aren't. We're going to wait till the end, and then we will do more. Let's do an MVT, and then we're going to start mixing them up. So mean value theorem, mean means average, okay? So mean value theorem basically says if a function is continuous and differentiable, continuous on the closed, differentiable on the open, then the slope of your secant line, which is your average rate of change, has to equal the slope of the tangent line, which is the average, is the instantaneous rate of change. Okay? So your derivative has to equal the slope of this. So this would be f prime, and this would be f of b minus f of a over b minus a. So the formal statement is this. If f is continuous on the closed, differentiable on the open, there exists a c on the open such that the derivative equals the average rate of change. That's our basic idea here. So here's your statement. Since f is continuous on AB and differentiable on AB, by MVT there exists a c on the open interval such that f prime of c is f of b minus f of a over b minus a. That's what we're saying. So let's look at an actual one of these. The twice differentiable function, so that means I can take derivative twice, got it, is defined for all real numbers. Selected values are given in the table of f and f prime. This says, write an argument to explain why there must be a value where f double prime equals 0. Now I'm given f, I'm given f prime. I'm not given f double prime. So I'm going to look at f prime for this because I'm taking the derivative of it. So here's what I'm going to say. Will that equal 0? Well, let's find our average rate of change. So f double prime is going to be approximately f prime of 3 minus f prime of negative 3 over 3 minus negative 3, which just equals 0. So my average rate of change is 0. So MVT is going to mean, or to tell me that this is true. So here's what I would say. F is differentiable and therefore continuous on negative 3 to 3. Okay, since f is twice differentiable, f is differentiable. And we can add that in. Since f is twice differentiable, f prime is differentiable and therefore continuous on negative 3 to 3. Thus, MVT states that there exists a c on negative 3 to 3 such that f double prime of c should equal f prime of 3 minus f prime of negative 3 over 3 minus negative 3, which is 0. Done. All right, let's do one more. So this one, hot water is dripping into a coffee maker. The amount of coffee in the cup is given by C. C is in the table. And I'm going to look at part B. Is there a time on 2-4 at which C prime of T should equal 2? I'm given C. I'm asked about C prime. So I know this is MVT. So I'm going to look at 2 to 4. And let's just kind of think about this logically. So if you do the average rate of change there, your change in Y is 4. Your change in X is 2. So your slope there would be 2. So this is true. So here's what I could say. They tell me this is differentiable. C is differentiable. I did not leave myself enough room. Therefore, continuous on 2 to 4. So by MVT, there exists a T on 2, 4 such that C prime of T equals c of 4 minus c of 2 over 4 minus 2, which I know equals 2. Okay. And then the last thing is Rolle's theorem, and Rolle's theorem is just MVT. You can call it MVT. You don't need to call it something different. But all Rolle's theorem says is that your average rate of change has to be 0. So if you do f of b minus f of a over b minus a and you get 0, that could be Rolle's theorem. Same thing. All right, so these we did in class, but I wanted to go through them one more time to make sure we understand which you'd use when. So this is the same problem that we did before, the coffee one, but let's say would this be IVT or MVT? So remember that we're given C, and here I want to know, is there a time where C would have to equal 10? Well, if I'm given C and I'm asked about C, that's IVT, right? The same function I'm given. Here I'm given C and I'm asked about C prime because I'm taking a derivative, I'm talking about the rates of change, that's going to be MVT. Now on this one, I'm given G and I'm asked about G prime. So I see that I'm finding a rate of change, so differentiability, and that means we need MVT. Same thing here. So we're given G, we're asked about G, that's going to be IVT. So use IVT when given, let's say F, and ask for a value of F. Use MVT when given F and ask for a value of F prime. And try both if you're given both. If you're given, because one might seem like it doesn't work, but the other might. We're going to look at a question like that in a second. So we're going to go through a couple weird multiple choice, do a couple free response. I'll take any questions, and then we'll hang it up for the night. So this first one, F is continuous on the closed interval from -3 to 6. Okay, continuity, good. F of -3 is -1. F of 6 is 3. What does IVT state? So IVT, intermediate. So immediately I'm throwing out that. It's asking about F prime. That's going to be MVT. Okay? So I know that this is saying this starts at 1 and ends at 3. So if you actually think about graphing this, at -3 it would have a point at 1. At 6 it would have a point at 3. And all IVT tells me is that it has to hit every point between there. So, does f of 0 have to be 0? No, it does not. And actually, this one's at -1. So, that would be like down there. It doesn't tell me where it hits 0. I don't know. Does f have to stay between -1 and 3? No. In this original picture I drew, it does. But it could go like this and come back down. All I know is that it is there at the start and the end. Now this one says it has to equal 1 at some point between -3 and 6. And this one says it has to equal 0 at some point between -1 and 3. And it does need to equal 1 and it does need to equal 0. So what we really need to look at here is these. If we're talking about IVT, we're talking about between these x values, right? Between -3 and 6. And so it has to be D because E is talking about y values. All right, let's get a little harder. What's the next one I highlighted? Okay, this isn't that much harder. So the next one is this. The function f is continuous on the closed interval from 0 to 2 and values given in the table. The equation f of x equals 1/2 x has at least 2 solutions if k equals what? So let's think about this picture, right? At 0, it's at 1. At 1, I don't know where it is. At 2, it's at 2. And I want to know where f of x equals 1/2. So we want it to equal 1/2 twice. If k was 2, let's say, let's start at D. If k was 2, if this was here, this would never actually need to go down and equal 1/2, right? So it won't be that. If k was 3, same argument, right? That would be up here. It would never have to go down and hit 1/2. If k was 1, that would be here. It would never have to hit, right? So what about if k was 1/2? If it was right on that line? Then that could just be tangent there. We don't know. And so it's not going to be that because we don't want it to just be tangent. But if k equaled 0, it would have to cross once there. Nope. And once there we go. And so that would be where we know it would have to cross twice. IVT. All right, next one. F is continuous and differentiable. The table above gives selected values of F on this interval. Which of the following statements must be true? Anytime you have a table problem like this, consider what you really know. You don't know the stuff that happens between the points on the table, okay? So this looks in my mind like it might go like this. 2, 3, 4, 3, 2, right? But here's what I don't know. I don't know if it jumps way up to here or way down to there. It could do like crazy stuff in here. I really don't know. All you know are those values. So be very careful what you assume. Is the minimum value 2? Well, in the table it looks like it is, but I don't know what it does. So it's not A. Same argument for B. I don't know. Is F always positive? Again, it looks like it in the table, but in this picture I just drew, it's not always positive, so I don't know. F prime is negative between 2 and 4. So is this always decreasing? I don't know. I know it looks like it from the table, but I really don't know that. So I know it needs to be E. Here's what E says. There has to be a point where the derivative equals 0. Well, I'm given F. That's F prime. So let's find the average rate of change. So F of 4 minus F of 0 over 4 minus 0 is 2 minus 2 over 4. And guess what? By MVT, that would be true. Okay. Let's look at another one. So these tend to be tricky, especially these, like, when they all look the same. So F is continuous and differentiable. F of -2 is -5. F of 1 is 4. Which statement could be false? So if you're asked which is false, it might help you to think about, well, what do I know is true, right? So here's what I know. IVT. IVT would tell me it needs to hit all values between -5 and 4. So let's go through and eliminate any of those. That F needs to hit all values between -5 and 4. So F would have to hit 0. Absolutely. F would have to hit 3. Absolutely. And B and D are unrelated and E is unrelated. So I've eliminated those by knowing what IVT says. MVT says that your average rate of change has to equal your instantaneous. So your average rate of change here would be F of 1 minus F of -2 over 1 minus -2. So that's 9 over 3, which is 3. So here's what this says. That my derivative must equal 3. Guess what? That means D is true. Now, I don't know about B. I didn't just prove that. So my guess is that B is the one that's false. But let's look at E. E says there has to be a point where F of C is greater than F of X for all values. That's EVT. This is saying that this is the absolute max. And as long as this is continuous on a closed interval, it must have an absolute max. So this is true by EVT. So this one has to be B. Okay. We're not going to do all of these, but let's pick one more. Let's do 8. 7 and 8 are the same. 7 is just a calculator question. So 7 says, let this be the function, F be the function. What are the values of C that satisfy the mean value theorem on the interval from 0 to 3? So I know it's continuous. I know it's differentiable. It's a polynomial. So what I know is that F prime of some value should equal F of 3 minus F of 0 over 3 minus 0. That's what MVT says. So I'm actually going to calculate this. So F of 3 would be 27 minus 27, okay, minus 0, okay, over 3. So this is 0. So what this tells me is that my derivative needs to equal 0 at some point. So I'm going to take F prime, which would be 3x squared minus 6x, and set that equal to 0. That's going to give me those for my zeros. So x equals 0 and x equals 2. So what values should I pick then? What values should I pick? Well, an endpoint cannot satisfy mean value theorem. There is no derivative at an endpoint. So it can't be 2, so we're going to reject that. So it is only A, 0. Okay. All right, let's look at some of these ones where we're actually doing some free responses. So, especially some of the weirder ones. Let's look at this one. This was on one of your quick checks, but still good to go over. So Ben's riding his unicycle back and forth along a twice differentiable track, or track modeled by a twice differentiable function. The table is given, and notice we're given his distance and his velocity. So this is when I say if you're given both, think about this, okay? Is there a time where his velocity must equal 2 meters per second? So my gut reaction is they're asking about velocity. Let me look at velocity. So on 40 to 60, does it look like there that needs to equal 2? I would argue no. So IVT does not prove this. But the problem is we're given his position curve. And so let me look at position between those two values. So what if I did this? What if I did B of 60 minus B of 40 over 60 minus 40? Well, that gives me 40 over 20, and guess what that equals? 2. So, is there a time where his velocity must be 2? Well, there is a time where his average rate of change is 2, so there has to be a time where his instantaneous is 2. So what I would say here is, yes, since B of t is differentiable and therefore continuous on 40 to 60 by MVT, and I'm copying here, literally. There exists a t in 40 to 60 such that B prime of t, which happens to be V of t, equals, I'm going to fit this in, B of 60 minus B of 40 over 60 minus 40, which equals 2. Done. So don't be fooled if something doesn't work the first time if you're given both sets of values. Okay, next one. This is a nasty one. This is actually a BC problem, but I think it's a really good problem. So let's talk about this one. A cylindrical can of radius 10 is used to measure rainfall in Stormville. The can is initially empty and the rain is entering. Here's what we know. The rate at which the height of the water is rising is S prime. And the height of the water in the can is modeled by M, where M is that. So here's what this tells me. The height, or let D equal M prime minus S prime. Apply IVT to show that there exists a time between 0 and 60 at which the height of the two cans are changing at the same rate. So think about this. If they're changing at the same rate, then wouldn't M prime of t and S prime of t be the same? And if they're the same, we want to show that D of t equals 0. And as soon as I see IVT, I think, okay, I'm going to use D of t. I need to figure out these values. I need to sandwich this between two things. So I'm going to look at D of 0. I'm going to look at D of 60. For the sake of time and the fact that you could just plug these in your calculator to find them out, I'm going to tell you that that one is negative and that one is positive. And so now what's your argument, right? So since D is differentiable, right, they tell me it's differentiable. It is continuous on 0 to 60. We don't need differentiable for this, but that's how we know it's continuous. Since D is differentiable, it is continuous on 0 to 60. And 0 is greater than D of 0, which is less than D of 60. Therefore, there exists a t between 0 and 60 such that d of t equals 0, meaning m prime of t equals s prime of t. Very difficult to analyze, a lot going on, but what you need to think about is IVT, sandwich it between, right? And then look at the endpoints and make sure that value you want's between it. All right, I think I have 2 more and then we'll do questions. All right, maybe only 1 more. All right, so continuous function is given. The graph of f consists of a line that is tangent to the x-axis there on the interval 0 to 6. F is twice differentiable with f double prime greater than 0. C, is there a value of a between -4 and 6 for which MVT applied between a and 6 guarantees a value of c such that the derivative equals 3? And a lot of people look at this and go, nope, because it's not differentiable, right? There's a cusp there, so it's not differentiable. Not the case. They're asking me, is there a place where it is differentiable? And what I saw here is that it told me on this interval that puppy is differentiable. So let me only look at that part of the graph. Is there anywhere where my slope, my average rate of change is 1/3? Well, from 1 to 6, it goes down, so definitely not. Or 0 to 6. From 1 to 6, your slope is 0. From 2 to 6, your slope is some unknown value that I'd have to calculate. 3 is at 0, so good guessing point of a place to start. That's at 0. It's probably good. Up 1 over 3, that has a slope of 1/3, right? So what I would say is, yeah, there is. If I say a equals 3. So a equals 3. That's what I'm saying. That's what I'm claiming is my value. So I would say since f is continuous on 0 to 6, we know that it's always continuous, and differentiable on 0 to 6. And actually, I'm not even going to use 0. I'm going to use 3 because that's my a value, right? F is continuous on 3 to 6 and differentiable on 3 to 6. So there exists a c in 3 to 6 such that f of 6 minus f of 3 over 6 minus 3 equals, or such that f prime of c equals that, which is 1/3. So really read the question and make sure you don't just jump to the first conclusion. Okay. This next one, does MVT guarantee a value applied on the interval from -3 to 7? Well, on that interval, it's not differentiable. So this would be no because it's not differentiable. The coffee drip one we did. The zoo one is EVT. We've done that. All right, let's do maybe these last couple. Okay, so we've got this here. This is my table of values, and they're telling me that h is this. So explain why there must be a value between 1 and 3 where h equals -5. So here's what I'm going to do. I'm going to find h at those values because I know this is IVT because I am given h, I'm asked about h. So first thing I'm going to do is find h at those values. So h of 1 and h of 3. Find your endpoints. So this is f of g of 1 minus 6. This is f of g of 3 minus 6. So let's calculate those. So g of 1 is 2. F of 2 is 9. G of 3 is 4. F of 4 is -1. So I see that I start at 3 and I end at -7. Do I have to hit -5? Yes. So here's what I can say. Since f and g are differentiable, and I would write out differentiable, h is continuous on closed interval 1 to 3. And we know that h of 3 is less than -5, which is less than h of 1. So, and I'm going to copy this. There must be a value of r, blah, 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 blah. There exists an r on 1 to 3 such that h of r equals negative 5. And go back to the prompt, right? Copy it right from the prompt. 2007, my favorite question. Average was a 0.98 on that question. Okay, last one we're going to do for today. F is twice differentiable. F of 2 is 5. F of 5 is 2. G is f of x. Part A, explain why there must be a value of c where f prime of c equals negative 1. Okay, let's do that. So I'm given f. I'm asked about f prime. So you know what I'm doing? MDT. So first thing I'm going to do is I'm going to calculate my average change and make sure this works out. So I'm going to do f of 5 minus f of 2 over 5 minus 2, which is 2 minus 5 over 5 minus 2, which is negative 3, or negative 1, negative 3 over positive 3. So I know this works, so now I just need to defend it. So I could say, since f is differentiable, it is, and you're going to write out differentiable, it is continuous on 2 to 5, closed interval. This is going to scare me. If I don't do it, someone might not. Differentiable. F is continuous on 2, 5. And then go back up here. Therefore, there exists a C on 2, 5 such that f prime of c equals, and then you're going to put that rate of change in. F of 5 minus f of 2 over 5 minus 2, which is negative 1. And that's what you're doing. Okay, I'm going to hang out for a minute. If you have any questions, send them to me. We are so quiet tonight. But thank you for those of you that have hung out with me the whole night. And if you're watching this on the replay, thank you for watching on the replay. Continue to send me questions, and I will see you guys later.